Hey everybody, hope everybody's having a good weekend here. Finishing out the weekend actually, and not a whole lot of weather going on here, so we're just looking at planets like Venus here. Still the evening star. You can see it to the southwest. And also we've got a little bit of a Earth shadow effect. I don't know if you can see that, if you see those streaks reaching up. This is caused by the Serrano del Burro Mountains near Del Rio, casting shadows about half, maybe a third of the way over this way. This is kind of the scale it's operating at. So you're seeing basically shadows against dust up in the stratosphere. And the stratosphere is a very, it's a layer where a lot of particulates tend to settle and stay put for a while, like volcanic dust, because it's a stable layer and there's not much vertical movement. So clear skies across Texas here, and temperatures have fallen into the 40s and 50s across much of the state, and you can see by the dew points here, very dry air mass. Oh, and just as a note, I figured out what was going on with the microphone, so you probably notice the sound is a little bit better. Well, I found there's this setting in here under microphone, under properties. Somehow this got reset and bumped down to 42, so it sounded like this last night. So hopefully that's an improvement for some of you there watching the webcast. About the only place with any weather going on across the country is up in the northeast. Got a continued northwesterly flow off the Great Lakes, so we've got a little bit of this lake effect snow going on in Michigan. I'll see if I can pull that up on the radar. I brought up AWIPS, and they're having some snags there. The model data is not coming in there. The radar is unaffected, so I'm going to pull that up. But in the meantime, let me try to bring up the NAM vorticity and see if that comes up. We'll probably have to wait for a few minutes for that, but anyway, I'm going to let that run for just a little bit in the background. And let's see what's happening out on the west coast. It has definitely calmed down quite a bit. We've shut off the Pacific feed of systems coming in from the ocean. We do have another one lurking out there. Let me find my window here. And there it is, off the California coast. So that'll be the next thing we're going to look for here. Right there, that's going to be the warm front sector. Here's the cold front. So that's going to be making its way probably to the northeast, maybe towards the Pacific Northwest. We've seen some moderation of the Great Basin highs, so thicknesses have come up quite a bit there. But here's that big blob of cold air over the east coast. And we see offshore a little bit of a baroclinic leaf system. We can see that on the satellite here. It's got that S shape on the back side there. So jet stream is going to be pretty much running along that back side of there. We've got subsidence on the left side of that jet and some upward motion here. And let's see, what else do we got going on? Let me take a look at the temperatures real quick. These were the high temperatures today across the country. Actually getting some 70s there in southwest Oklahoma, as well as in South Texas. And a few 60s sneaking up into Kansas and southwestern Nebraska there. If this keeps up, I don't know how many of you are going to be at the Chaser Con, but that would be quite interesting to have 60-degree weather there when that goes on. There's the northwesterly flow across the North American continent, large ridge across western Canada right there, and there's the trough embedded in that cold air on the east coast right there. So as you might guess, the main active frontal zone off the East Coast out in this area. And then as we talked about last night, this is the area of high pressure. So the baroclinic high is most favored in that area right there over the Dakotas and Nebraska. So we've got a little bit of a reflection of that, not exactly a high pressure area, but a little bit of ridging there, and a conspicuous absence of the lee side trough right now. Okay, and let's see if we can take a look at a sounding. I think University of Wyoming may still be broken. Server's probably down this weekend. So I'm going to bring up UCAR once again. Fort Worth sounding, looking pretty dry there. But we're starting to get a little bit of warming in the upper troposphere as that large ridge approaches from the west. Still northwesterly flow aloft there in Texas. And let's take a look at a sounding way up north. Let's try Glasgow, Montana. Pretty much the same thing, but we also see some more warm air and a very high tropopause there with that ridge building in. Okay, I've got a little bit of a sounding module set up that we can take a look at. I'm under kind of a time crunch this evening, so I'm going to have to go through it kind of quickly. But I'm going to go ahead and close out this forecast session here with the GFS data. And then we'll move on to that. Okay, let me get the GFS set up here. Okay, there's our picture for this evening. And you can see the front there right offshore. And quite a bit of a warm-up here in the Central Plains. You see the 540 line pushing well to the north up into the Dakotas. So may start getting a little bit of a warm-up there in North Dakota where Fred is, hopefully. I don't know, what did we see up there? Let's still 28 degrees there, but 55 at Rapid City, so maybe a little bit of relief there for North Dakota on the way. So for tomorrow's webcast, heading into the work week, Monday evening, looking at that Alberta Clipper coming through Illinois and the Great Lakes and Wisconsin. There's the warm front, there's the cold front. So I guess we're going to get a bit of a cool down for the Dakotas. Well, that's too bad. Going into Tuesday, another quiet day, but we see a little bit of anticyclogenesis here in Alberta, so that's going to push a little bit of cold air down in this region. Getting a little bit of baroclinicity there in Idaho and Montana. And we see that really start to come together here. Probably some good gap winds, valley winds coming through here. So Thursday going into Friday, migratory high kind of pushes southeastward, and that should give another little cool down for the central Mississippi Valley right in here, maybe moving into North Texas. And then for Saturday, we break out some showers as we get some flow from the Gulf. And maybe a little bit of isentropic lift with these thickness lines kind of piled up like that. Let me move that so you can see that a little bit better. So there's the flow off the Gulf. You can see those isobars reaching out into the Gulf like that. So that's the southerly gradient coming up this way. And then there's the thickness lines showing we have a regime which favors isentropic lift over that if we get southerly flow near the surface or just aloft. Then going into Sunday and Monday, bit of a frontal system moving through the southeast U.S. May get some showers through Mississippi, Alabama. Then Monday and Tuesday looks like something new here. Bit of a stronger system going through Texas. This is February 7th. So we'll kind of watch that and see what happens. with the models on that. And then just more of the same, kind of a northwesterly flow. Cold air over the east, warm air over the west. Kind of like what we have right now with downslope over Kansas or Canada and the Montana Rocky Mountain region. Okay, let's see what's going on here in chat, and see we've got the usual guests here. Flurries in South Indiana from Sue there. Let's see here. 4 to 6 inches where Robert is. Kevin mentions a few weeks ago we switched from GR level 3 to 2 to look at the Arlington storm. Is there a great advantage to using GR level 2? Well, GR level 2 has the base data at full resolution, whereas GR level 3 has most of the derived products, and the resolution is slightly lower with that, depending on which product you're looking at. I prefer GR level 2 because I'm kind of tied into the base products with full resolution, and I really don't make too much use of like the TVS and Hale products. I guess I probably should, but yeah, you can figure out what works for you. GR level 2, like I said, full resolution data. And let's see here. Weather viewer 62 for a high there, Tampa. Sarah Wood saying a couple inches of snow there in Indiana. Okay. Okay, let me take a look at my phone. I'm getting a whole bunch of messages come in, so I got to make sure there's not an emergency or something going on here. Just give me a second. Okay. Okay, let's see here. Let's head into our little lesson plan. So we're going to switch over to Microsoft Office and look a little bit at soundings. And this is going to be kind of an introductory lesson. So this will kind of give you an idea what soundings are for those of you who are kind of unfamiliar with working with them. If you want to actually start looking at soundings, the place to go to, just go into a search engine and put soundings at UCAR. And that'll take you to the upper air page there at UCAR, and that's where you can actually look at live soundings every 12 hours. So the Fort Worth sounding will look like that. So what are the soundings? We'll do probably about 10 or 15 minutes of this and just kind of go through this. Sounding is basically a way of looking at temperature and other properties against height. So you have temperature on your x-axis like that, so you're cold on this side and warm on that side. And then height is going to be your y-axis. So increasing height, you have the ground here, mid-levels here, and upper levels here. And there are slightly different ways to display this data. This is a tephogram here. You can tell because the lines are kind of curved. Let's see how to, I'm trying to figure out how to go forward. I guess I have to use the scroll bar. Okay. There's something called the Refstall diagram. That's something from the 20s and 30s. We have an emigram. And basically these are different ways to display properties of energy. There's the tephogram right there. And this is the SKEW-T diagram right here. So with that, your pressure lines are horizontal. Your temperature lines are skewed up and to the right. And that's pretty much all there is to that. So we can take a look at each one of those. This is a look at a SKEW-T chart. And remember, this is a kind of sounding, so a sounding can be a tephogram or an emigram or a SKEW-T. But a tephogram is not a type of SKEW-T. A SKEW-T is basically its own thing. So each line we have pressure. Pressure is horizontal lines. And these are calibrated in millibars. So 1,000 millibars, depending on the temperature and density of the atmosphere, that's typically going to be about 300 feet above the ground, but it can be well underground or a couple thousand feet up. 850 is going to be quite a bit higher, up around 5,000 feet normally. And 700, that's what we use for capping inversions. That's going to be up at about 10,000 feet most of the time. So it's kind of good to know those and have a basic idea how high your 700 millibar level is and you're at 50 millibar level, and to be able to interpolate between the two. So if you have a height of 775 millibars, you'll know that that's halfway between 700 and 850, which is going to be halfway between 10,000 and 5,000, which means about 7,500 feet or so. Okay, and we'll go to the next one, temperature. So this is essentially SKEW-T. The temperature is calibrated in Celsius degrees, but at the very bottom we've got a Fahrenheit scale. Your better SKEW-Ts will have that calibrated at the bottom in Fahrenheit. So if we have a point here, you're going to want to know how to obtain the temperature, and you just read it against this scale here. So we can see that mark right there is between the 4 and right there, that's the 3 and the 4 line. So that's going to be about 3.5 degrees Celsius. And likewise, how high is that? Or what pressure is that? That's going to be between 800 and 810 millibars. So that'll be roughly about 6,000 feet. Then another line we have is the mixing ratio line. And that's usually a dotted line that slopes up and to the right. And this is a measure of moisture. It's very similar to dew point. So the further your moisture line is over to the right, the more moisture you have. So on the sounding, we have two different lines. We have the temperature line. It's going to look like that. And then we have a moisture line, which is usually going to be green. But it'll be the line that's off to the left. And so you're going to read mixing ratio against that left line there. And that'll give you an idea how much moisture is in the atmosphere. So this part of the line right here, that's going to be about 8 grams per kilogram of moisture. And you may wonder why we don't just use dew point. Well, mixing ratio is conserved. So if we have a moisture line like this, no matter where we move that parcel to, up or down, the mixing ratio is always going to be 8 grams per kilogram. But if you move it around like that, the dew point for that parcel will change depending on where it is. So mixing ratio is a better way to express that in terms of the physics of the parcel. Okay, then we have the dry adiabat. We have two kinds of adiabats on here. The dry adiabat is when a parcel is not saturated and we raise it or lift it, or we sink it, which is subsidence. It's going to rise or cool along that line. So if we assume the initial pressure of a parcel is 900 millibars with a temperature of 9 Celsius, and we want to know what the temperature is going to be if we lift that up to the 800 millibar level, all we have to do is plot it and then bringing up to 800 millibars along that line, and we get a temperature of 0 Celsius. And this basically approximates the temperature change of 5.5 Fahrenheit degrees per 1,000 feet. It's kind of a way of plotting that. Then we have the wet adiabatic, and when we have a parcel that is saturated with a relative humidity of 100%, when we lift that, it's going to cool at a slightly reduced rate. So it's going to hang on to more of the heat because of the addition of latent heat. So if we start with 1,000 millibars and 10 degrees Celsius and we want to lift that up to 800, then it's going to cool to just under 0 degrees Celsius. So that's how that works right there. So you're going to use that in a severe weather situation if you're looking at capes. Capes, that's a big one right there. You're going to end up lifting a parcel till it reaches its LCL, and then from there you're going to lift it along the wet adiabatic or the moist adiabatic. Same thing. And if you compare that against the existing sounding, which might be something like that, the area in between that and your lifted parcel, the amount of that area is going to be proportional to your cape. And we've got a height scale that applies if we have a standard atmosphere. And you can see 850 millibars with a standard atmosphere that's going to be just under 5,000 feet. So you can use that as a bit of a cheat sheet right there. There's another look at a sounding. Then I'll take you through a couple of the different kinds of inversions. I think I've got this on here. No, I don't. Well, at least I can show you basically what an inversion is. That's where we have warm air above cold air near the ground. So you can see that the temperature actually rises with height. So down here we've got about 8 degrees Celsius. No, I'm sorry, I'm reading that wrong. This is -1 Celsius. See, there's -5, there's 0. Or actually, 0 is way up here. So yeah, this is going to be -1.5. This is going to be positive 1.5. Okay, let's see here. I'm trying to figure out how much I want to get into this for tonight. I may have to leave things here because I've got an IFR column that's due, and I've got to check on my kid and make sure he's okay right now. And I'm doing the next IFR article on aviation accidents, so I'll give you a sneak peek of what I'm covering, and you might be kind of surprised at this. There was a pilot on, I'm trying to remember the date, I think it was June 18th of 2014. He flew into a supercell near Lubbock. And I'll show you this real quick. So this is what I'm covering for that article. So this is that plane. He's flying from Aspen, Colorado to Brenham, Texas. And this is southwest of Lubbock, and you can see him flying down like this. And he's looking for a break in these storms. And you can see he had a break up to the north, and there's gaps to the south. So he decided to turn left and fly into the storm. And then right in here, he started losing altitude and crashed, and there were 3 fatalities for that storm with that crash. So that's kind of puzzling why that happened, and I'm kind of looking a little bit into that. Okay, so that's probably about all I got for tonight. I'm going to have to get going on this article and get that turned in. And maybe we'll cover some more stuff like that this week when things calm down a little bit. All right. Well, guys, I think that'll do it for me. I appreciate you watching, and we'll see you again tomorrow night.